word problems that involve inequalities. Okay? So you're going to hear words like at least, or at most, or greater than, or less than, okay? Or at a minimum, or at a maximum. What is the amount of calculators that need to be sold to make a certain amount of profit? Okay? Or at a minimum, how many cups of lemonade have to be sold to make this much money? So you give a minimum answer, so it's a range of answers. It's at least 5. So 5, 6, 7, 8, 9, or y is greater than or equal to 5. So we're going to see in this section. Okay, and I just said exactly what's on the next slide. Okay? So at least, if it's at least, it means it's greater than or equal to. If it's at most, let's write these down. At least. If I said, I need at least $6 to have lunch today, I could have $7, that'll work, right? I could have $8, but at least 6 means greater than or equal to that amount. At most, bless you. At most means the opposite, so it means less than or equal to. No more than. That's a good one. No more than. If I said I can give you no more than, no more than 2 more days to finish the assignment. No more than 2 more days. What does that mean? Less than or equal to. And then no less than. If I say, you know what? I'm finishing this homework assignment for you guys, or I'm grading, but it's going to take me no less than 3 days to grade it. So it's going to take me 3 days or more, right? Greater than or equal to. So that's what those words mean when you see them in the context of a word problem. Okay? We've got it. We're away from equals now, and now we're looking at inequalities. A store charged $5.50 each for calculators and a delivery charge of $25 for the whole order. If the store sells the calculators for $8 each, how many must be ordered and sold to produce a profit of at least $86? Assuming you're selling them all, right? We're assuming you're selling all of them. No extra inventory. Give me a let statement. Let x equal what? What are we looking for? What's the problem asking for? Well?
How many calculators do you need to sell?
Good. So number of calculators. Okay, number of calculators. Now, if I want to make a profit of at least $86, profit equals what always? In any economic situation, just common sense, profit is what?
What do you make?
So give me the actual math behind it. You take the amount of money you get, and what do you do from that?
Subtract the amount of money it took to make or deliver.
The cost. So the revenue minus the cost. Those are the terms, but you just remember, however much money comes in, minus however much money you spent in order to get these objects, that is the profit. Okay, so if you want to jot that down, you can. You can say profit is always equal to revenue minus cost. Not something you should have to memorize, it's more common sense. If it cost you $20 and you brought in $50, you made $30. It's whatever the difference is. Okay? So the profit is what? At least $86. So the profit needs to be this quantity. So this quantity needs to be at least $86. So what do? How do I write that down? R minus C has to be?
Greater than or equal to. Yeah, greater than or equal to 86.
That's it. Remember, the profit is revenue minus cost. And the profit needs to be at least $86. So greater than or equal to $86. Now the question comes into play. What is your revenue? How much do you make per calculator, Kelly?
8 times X.
Good. 8 times what? X, you said? X, yeah. So 8x. Yeah, I heard time, so I thought you were saying a number. So yeah, the revenue you get, you take in $8 for every calculator. Paul, if I sell 5 calculators, what's my revenue? 40. 8 times 5, right? 8 times 5 calculators. That's my revenue portion. Now, I have to consider the cost of each calculator and the cost of the shipment. How do I do that, Rye?
550x 25.
Plus 25. Why is there no x, Nina, next to the 25? Why is it only next to the 5.5?
Because it's just a delivery cost, it doesn't really matter how many calculators you buy.
Yeah, very good. It's like the y-intercept, isn't it? It's a flat rate or it's a flat fee added on. 5.5 is like your slope. X is your independent variable. 25 is like your y-intercept. It's like saying, even if you order one calculator from me as a company, you got to pay me 25 bucks minimum just to get it delivered, and then $5.50 per calculator, which makes people want to do what? Buy many at a time, so you don't have to pay that shipping fee multiple times. It's called bulk ordering, right? That's why you buy in bulk. That's how Costco works. Okay, so at this point we're good. What's the one thing that you think some students might forget that I made sure to emphasize in my equation? What do you think? Where's the room for error here? Sabine? Yeah. This distributive, this is a negative, the whole thing, isn't it? It's subtracting the entire thing, so now it really looks like this. Okay? So we need to distribute that negative to both terms in the parentheses. And it makes sense. Cost is negative. And both of these terms, this 5.5x and this 25 are both negative because they're both part of the cost. This is the revenue, so it's positive. This is the profit in the end. What do I do at this point? Solve, right? Combine like terms and solve. So I'm going to put the answer up. You get x is greater than or equal to 44.4. Now, let's use common sense. What's the actual answer?
45.
Yeah, because?
You have to round up and you're using like money and not like change.
Not the money. What is x? X is the number of calculators. So can you have 0.4 of a calculator? Can't order 0.4 of a calculator. So how many do you order? Since it's greater than or equal to, and you're looking for an integer solution, as the context of the problem gives you this answer. You need to order 45. Again, you can't order a fraction of a calculator, so you have to go up to the next possible integer value. Okay? Questions on this? Any questions on this? This is our starting point. Okay? So we'd say you order at least 45 calculators. Find 4 consecutive even integers whose sum is between 20 and 30. Nick, help me out with this one. I remember we were talking about this before. If I want 4 consecutive even integers, what could I call the first even integer? Pick a variable.
10.
Variable. Give me a variable. You want x, you want n, you want m.
X.
Meaning like whichever one you don't choose. X? Alright. So what would the next consecutive even integer be with terms of x?
Oh, 10.
Think about x as a number, like a random variable. So if x were like 14, what would the next integer be that's even? After 14.
16.
And then 18, and then 20, right? So you increment by 2. So if x is the first integer, the next one is 2 bigger than x. So this would be the second integer. What's the next integer after that?
4.
X plus 4. And the next one?
X plus 6.
Good. So those are my 4 integers, right? They're consecutive even integers. If x happened to be 10, this is 10, 12, 14, 16. If x were 20, 20, 22, 24, 26. Consecutive even integers. So I always start with that. Even if it said odd integers differ by 2 still, don't they? So odd integers, even if it said odd, it would still be the same exact starting point. Now, here's where it gets tough. We're told that the sum of these is between 20 and 30. Between. Not equal to, not greater than, not less than, but between 20 and 30. You can't include 20 and 30, or else it would say including 20 and 30. Or inclusively, it would say at the end. So if it's between 20 and 30, it means that the sum of them could be anything from 20, above 20, like 20.1. But they're integers, so it's not going to be. So 21 through 29 are the possible numbers it could be. How do I write a statement like that? How do I write a statement like that? Luca.
5 to 20 is less than x plus x plus the quantity of x plus 2 is 40, x plus 4 is 40, x plus 6 is less than 30.
Very good. I'm going to move over. I ran out of space. So let's discuss. I'm going to point and talk. So if you're confused, just look up. Ready? The sum of the 4 consecutive even integers, that's this, is between 20 and 30. These are my endpoints on the number line. It's saying that 20 is the lower limit, 30 is the upper limit, and the sum of these is somewhere in between. Okay, somewhere in between. So I've got a less than sign here and a less than sign here. Before I break this up, like Paul did for us earlier, let's combine all the like terms here. There's 4 x's I can see, and 2 plus 4 plus 6 is 12. So I don't do anything except for combine like terms in the middle area. Now I'm back to section 2.2 with a compound inequality that has an AND statement. I know it's an AND statement because I can see that there's one term in the middle and the endpoints on both sides. That reminds me it's an AND statement. Break it up, Mike. What do I do? What do I get? Break it up into its components now. How do I solve this?
It's 20 is less than 4 is 12. And 4 is 12 is less than 3.
Good. So remember, you're going to use this portion of it once, and you're going to use this portion of it once. Okay, and you break them up. So that middle term gets repeated, but the endpoints stay the same. And then you just solve. Subtract 12 on the left-hand side, divide by 4. You're going to get 2 on this one, where x is greater than 2, it looks like. And on the right-hand side, subtract 12 gives you 18, divided by 4 gives you 4.5. So what's going on here? What's going on here? Let's take a look at our possible solutions. Please read this as x is greater than 2. Although it's written as 2 is less than x, you need to read it backwards, please. X is greater than 2. So I put 2 on my number line here, open circle, shade right. I put 4.5 over here. Since x is less than 4.5, I shade left. It's an AND statement. I look for the overlap. The overlap is just between 2 and 4.5. So here's my solution set. But the question is not done. The question said, find 4 consecutive even integers. So that means that x has to be an even integer to start. What even integers are there that are between 2 and 4.5? And be careful.
4.
Just 4. Why not 2?
2, because if there's 2, then it can't be equal to.
Exactly. This would have to be shaded in, or this would have to be a less than or equal to sign, or the problem in the beginning would have said this. Find 4 consecutive even integers whose sum is between 20 and 30 inclusively, meaning including 20 and 30 as possible answers. And that's when you would have less than or equal to symbols. Instead, then you'd have shaded in circles. If these circles were shaded in, then the possible answers would indeed be 2 or 4 for the first integer. Remember, this is x, the first integer. So when I go back up to my answer key, when Nick started us off up here, since the answer, as Ben just said, was 2, it means that this is 2, which makes this 4, which makes this 6, which makes this 8. And 2 plus 4 plus 6 plus 8 is... Oh, you said 4. Sorry. I apologize. Because that would give us 20, right? I was wondering why we're getting the lower limit there. If we did that with 2, we'd get 20 exactly, which we don't want. We want above 20. 4, 6, 8, 10. Sorry, Ben. 4 and 6 is 10, 18, 28 as a total. Okay, so that's how I check that this is right. Add these 4 together, you're going to get a sum of 28, which is between 20 and 30. Paul?
You said that if it's 4, it's like 4 and then you have 1 number.
Yeah, on an OR statement, usually they go against each other in opposite directions. And usually it's like the solution is x is greater than 3 or x is less than negative 7. So then you'd have to pick or choose. For a problem like this, it's always going to be an AND statement. Whenever, if you want to write this down, you can. Whenever you have a problem that says in between 2 numbers, or you get a range of values from like 20 to 30, it's always an AND statement. Those are always going to be AND statements, those compound inequalities. Okay, whenever you're given a range of possible answers that you have to lie between, it's going to always be AND. All right? For us, let's go, Will, this one. Nice and loud, read.
During the first 20 miles of a 50-mile bike race, John's average speed was 25 miles per hour. What must his average speed to the nearest mile per hour
bigger the remainder of the race if he is to finish in less than 2.5 hours.
So what's your constraint? What's your constraint in this problem, Niall?
Yeah, still under 2.5 hours.
Under 2.5 hours. So total time needs to be less than 2.5 hours. Does that make sense? That's the only constraint right now. We know that during the first 20 miles of the race, all right, so let's now truncate this problem. What does truncate mean?
You like you only do like the first half.
Yes, separate into segments. So in the first 20 miles of the race is here, and then 30 miles of the race are here. In the first 20 miles, we have a speed of 25 miles per hour. And in the second race, we're trying to figure out what the rate should be. This is how I visualize problems when I read them. I say to myself, during the first 20 miles or 50 miles, so right away, make a 20 mile and a 30 mile segment. It says his average speed in the first 20 miles was 25 miles an hour. I write that speed right down below it. And then it says, what must the average speed be during the remainder of the race? So that's X miles per hour. You're trying to figure out X in this problem. Okay, what's my formula that relates these things that we should have memorized by now? It relates distance, time, rate, all that stuff. Yes. Here's our governing formula always. Write it down, please. D equals RT. I don't want to give you the easy way to do this. Can I get some ideas? Because this is tougher than it looks. When I tell you, you're going to be like, oh, it's so easy. But just looking at it right away, it's not that easy to figure it out. What do you think you'd have to do in a problem like this? Kelly, give us a stab. Take a stab at it.
Do we really have to worry about like the first 20 miles because they're not asking like in the rate in the first 20 miles because they're not really asking about that?
They're not, but part of the first 20 miles has to do with this.
Because we need to find out the
Right.
time for the 20 miles.
Well, we need to figure out the time here. Why is that? Explain your reasoning as to why you need to use this, Ryan.
Oh, we need to find the time because we need to do less than 2.5 hours, and we have to find out the time for that in order to find out the rate for 30 miles.
So hypothetically, Ryan, if this took an hour, right? How much time is left to do this part?
An hour and a half.
About an hour and a half. So although we're not using these directly, we need to find the time in both segments. That's why I started with time total. Because remember, time total, it's all right.
I thought the question, I thought it meant like the remainder of the race you have to finish in like 2.5 hours, not like the entire thing.
Gotcha. Yeah, the whole thing, 2.5 hours, yeah. So that's really the statement we're looking at. T1 plus T2 has to be less than 2.5 hours. What's T1? What's the first time going to be? If I solve for time, time is distance divided by rate. Distance divided by rate. What's 20 over 25 give us?
Well, it would be 1/3 times 25. Wait, 20 miles, sorry. 1/3 times 20 miles times what?
No. It's divided, right? Look, again, look at your formula. D equals RT. We're finding time. Solve for time in this formula. Algebraically, solve for time. What do you get when you solve for time? What's the expression look like? What's the generic solution for time if you solve for t in this equation?
20 equals 25.
Generic solution. Generic solution. Variables.
D over R?
D over R. D divided by R gives you time, right? Divide both sides by R. We did this, guys. You need to be able to do this by now. T is always distance over rate. We could write it that way. So the distance traveled, 20 miles, over a rate of 25 miles per hour. 20 over 25 is 4/5 as a fraction. So this is 0.8 hours. That's the time for T1. Ryan, follow up because I asked you this before. If that's the time for T1, what does it leave over for T2? How much time? 1 point. Yes, 1.7 hours. 'Cause if this is 1.7 hours and this is 0.8 hours, those add up to 2.5 hours. So really what we're doing is we're saying, let's go back to that original equation up top and let's take this and plug it in up here. So it's really 0.8 plus whatever the second time is, has to be less than 2.5 hours. Subtracting the 0.8 as Ryan did tells us that the second time has to be less than 1.7 hours. Well, if that is true, we could then figure out what the rate is to give us something less than 1.7 hours. So we know that the time needs to be less than 1.7 hours. This is the expression for time. I'm circling it over and over. D over R in the second scenario needs to be less than 1.7 hours. Okay, the distance over rate, which is really time, the time it takes needs to be less than 1.7 hours. We know the distance is 30 miles. How do I solve for R? This can be tricky. Some people make mistakes here, so I want to make sure we're clear on this part. How do I solve for R?
You multiply by R.
Good. That's the first part. And then
You divide by 1.7.
divide by 1.7. Okay, so it turns out that the rate has to be, and we're going to read it backwards, the rate or the speed needs to be greater than whatever this quotient is. 30 over 1.7, which is 17.64. Okay, so it needs to be, or the bike rider's speed needs to be at least 17.64, or greater than rather, 17.64. Can't be equal to, it's got to be a little bit bigger. So if you were saying to the nearest integer, you would say 18. To the nearest tenth, you would say 17.7. Because the nearest tenth needs to be the next one up. Because remember, this is read as R is greater than this quantity. So nearest tenth, you would actually answer with 17.7, not 17.6. Although rounding makes you think 17.6, you need to actually round up automatically. Because the symbol says it has to be greater than this. You can't round down because that number is less than this. Okay? Now, who's the person in this problem? John. If John traveled at a rate faster than this, he would just finish quicker. And he'd be under the 2.5 hour limit, for sure. But if he traveled any slower than this, his overall time would then exceed 2.5 hours, and he would not complete the race in time. Okay? I went through that a little quick. Do you have questions? Because I know there was a lot. I could scroll back up if you want to see the thought process again. Yeah, Paul?
I just want to know, is there going to be a problem like this on Friday?
Yeah, so at the end of the test, you're going to definitely have multiple choice to start. You're going to definitely have some shorter answer kind of problems. And then I give like 3 or 4 word problems at the end of every test. So remember the section 1.8 and 1.9? And then this section, that's where the word problems will come from. So you'll have about 3 of those problems. Sometimes I'll give you 4 and say choose 3 out of 4 to answer, and you can omit one of them. I'll probably do that for the first test, just to make it a little bit easier. But after that, sometimes I don't do that as much anymore. Okay, but you'll definitely have word problems in the test, and I will guarantee you that you'll have, if you have 4 word problems, 2 of them will probably be from section 1.9, like equations, and 2 of them will probably be inequalities, just because we've only done 2 sections with word problems so far. Okay? But again, the idea, that's just to reiterate, as I point, can somebody explain how to do this? Anybody think they really got this problem down? I'm going to point and you tell me what it means, each part of the step. Nobody really got this down? Should I go over it all again though? Here, what's going on? One step at a time then. What does this statement tell me, Nick?
This is telling you the time is less than 2.5 hours.
Good. So the time in the first part of the race plus the time in the second part of the race is less than 2.5 hours. That's this statement really. Although once we had this, we don't really need this anymore, right? Because the one above it does enough. In the first part of the race, we had this information. We had a distance and we had a rate. How do we figure out this time? Ben? Distance equals rate times time. So we solved for time, and we said time equals distance over rate. We took the distance over the rate. 20 over 25 is 0.8 units of hours. That's the time for the first leg of the trip. We then paused, and we said this. We said, all right, if the first leg of the trip is 0.8 hours, let's plug it in up here for T1, which is really showed up right here. So then we said, okay, if that's true, and we solve this, we end up with the statement that T2 has to now be less than 1.7. I got that by subtracting 0.8 from both sides. Subtract 0.8, subtract 0.8. you get that the second leg of the trip has to be less than 1.7 hours. Okay. Time, if we remember, is really distance over rate. And since time has to be less than 1.7 hours, that means that distance over rate, right here, distance over rate, has to be less than 1.7 hours. We know the distance is 30 miles, so we plug that in for distance. So 30 miles over whatever the rate is has to be less than 1.7 hours, the remainder time. Then, as Niall said next, we go ahead and we multiply by r to bring it up here, and we divide by 1.7. By the way, you'll notice this throughout the year. You can always flip-flop these. See this? Whenever you have distance rate, you can flip-flop a denominator with the other side if it's only have a numerator. Because really you're multiplying by r, and then you're dividing by 1.7. So just switch these two. Okay, that gives you r equals 30 over 1.7, which is approximately 17.64 miles per hour. And I need units, so let me write them. Okay, miles per hour. So to the nearest mile per hour, it would be 18 miles per hour, at least. Anything less than this, and John would not finish the race in time. Catherine's second test score was 8 points higher than her first test score. Her third score was 88. If she had a B average, which is between 80 and 89, inclusive, keyword, for the three tests, what can you conclude about her first test score? So here's where section 1.8 comes into play, right? Writing out those statements. So give me some let statements in this problem. Give me some let statements. Nina. Her first grade? All right. It's a good first let statement to start with. If that's true, then give me something else. Give me something about her second test grade. Niall.
Plus 8.
Why now? How come?
Because it says Catherine's second test score was 8 points higher than the first.
Okay, we all see that? So that's where that statement comes in. And then her third score is given. It's 88. So you don't really need to put that, although we'll write it just for the sake. All right, awesome. How do I find the average of three tests?
Add them all up, whatever.
The frequency, good. So in this case, 3. Add them up and divide by 3. That's the average right there. Now, Nick, back to you from the earlier question. Remember all the even integers and stuff? In that problem, we were told that the sum of them was between 20 and 30. So we made those the endpoints. What are the endpoints going to be in this problem then?
81, 88.
Be careful, it says inclusive, so we can actually include them now.
Oh, so 80 and 89?
Yeah, we're going to use these symbols now. Okay? We're going to use the less than or equal to symbols to indicate that she could have had an average of 89 or 81, because the B score is inclusive in that range. Now, this becomes tricky. Let me explain why. I'd sum everything on the top, obviously. Now you can break it up, or you can multiply everything by 3 to make it easier to start. Multiply all 3 parts of this inequality by 3. I multiply this by 3, and use red instead. Multiply this by 3, multiply this statement by 3, multiply this by 3. You can do that, as long as you do it to all parts of the inequality, giving us 240 less than or equal to 2x plus 96 less than or equal to 267. Does that make sense what I just did? Remember how in math, if you have a fraction, you multiply by the reciprocal? This is really like a 1/3. So 3 in the denominator tells me multiply everything by 3. These 3's cancel in the middle there. Okay, remember to cancel this 3 with this 3 right here in the middle. And then at this point, I've got an AND statement inequality. Okay, break it up. Break it up for me. Sabine, what do we got? Into 2 statements. And? Okay, and we'll solve these separately. So subtract 96 in both cases to start and then divide by 2, giving us a range of 72. So this one is going to be, let's see, x here This is going to be a 72. And this x is going to be here. And this is going to be a 85.5. Agreed? So, that means that her first test score is somewhere in between there. Inclusively. How would this look on a number line? Well, greater than 72 is this. Shade to the right. Less than 85.5, less than or equal to, is shaded to the left. And we knew it was an and statement, so I kind of predicted that it was going to look that way. All right? If the problem said that test scores could only be integer values, then you would say between 72 and 85. Okay? Couldn't say 86 though. You could not say 86 because that's outside the range. If it was only integers, you'd say between 72 and 85. It doesn't say that though. So anywhere between 72 and 85.5 works in this problem for her first test score. And obviously we chose X to be her first test score to make this answer easy on us. Right? You could be asked about the second test score. You then have to plug in both ends of that. So if her first test score was between a 72 and an 85.5, what would her second test score be between? What would her second test score?
72, no, 80 and 94.5, 93.
Why? How do you know?
Because it's 8 greater than.
Yeah, the second test score, remember, was 8 points higher than the first test score? So if this problem asks you to find a range of values with which the second test score could take on, it would be this range here. Just add 8 to 72, you get 80. Add 8 to 85.5, you get -3.5. So this is the first test scores range, the second test scores range, the third test score was just an 88. So there was no range for that test score. Okay, but that's how you would write the second one. You didn't need it, obviously. This problem only asks for this, but just in case, right? Just in case, so you know how to do it. Okay? Any questions? So this is very similar to problem solving, just like section 1.9. But instead of equations, now you have inequalities. It's really the only difference you're going to notice. All right? Do tomorrow, okay? Tonight, you need to finish your problem sets, wherever you're at, wherever it is right now. Now,